Welcome to a series of videos on solving trig equations. The goal of this video is to solve the most basic type of trig equations. Just like solving algebraic equations, there are several methods used to solve trig equations. It takes practice in recognizing which technique to use when solving trig equations. This video will explain how to solve trig equations in linear form with one trig function, and there will be several other videos that address different types of equations with different solving techniques. We want to solve each equation first on the interval from 0 to 2 pi, and then over all radian measure. So what we're going to do first is solve this equation for sine theta. So we'll add 1 to both sides, and then divide by 2. So sine theta must equal 1/2. First, we want to find all the angles that have a sine function value of 1/2 on the interval from 0 to 2 pi. Now we could use reference triangles, but in this case I'm going to go ahead and use the unit circle. Remember, the y-coordinate on the unit circle is equal to sine theta. So first, if we know that the y-coordinate will be positive 1/2, our angles must be in either the first or second quadrant. So we're looking for a y-coordinate of 1/2, and right away we see one here, 30 degrees or pi over 6 radians. Notice with a 30-degree reference angle in the second quadrant, that produces an angle of 150 degrees or 5 pi over 6 radians, and again the y-coordinate is equal to 1/2, therefore sine theta is equal to 1/2. So we have two angles on the interval from 0 to 2 pi that produce a sine function value of 1/2. So that takes care of the interval from 0 to 2 pi. Now if we want to find all radian solutions, remember that the period for the sine function is 2 pi radians. So if we take this angle and add any multiple of 2 pi radians, we'll have another coterminal angle with this angle, and therefore it'll have the same sine function value. So theta could equal pi over 6 radians plus, we'll say 2 pi k, where k is some integer. So this will produce some multiple of 2 pi radians. Or theta could also be 5 pi 6 radians plus 2 pi k. And that would produce any coterminal angle with this terminal side, producing a sine function value of 1/2 as well. Let's look at it graphically now. Here we have the graph of y equals sine theta and then y equals 1/2. These intersection points represent solutions. So the first two solutions we found from 0 to 2 pi were here and here. These other points of intersections would be obtained by taking one of these angles and adding a multiple of 2 pi radians. The distance from this point to this point is 2 pi radians, and the distance from this point to this point is another 2 pi radians. So you kind of see what's happening here graphically as well. Here we have another equation. Let's go ahead and solve this for cosine theta. So we'll subtract the square root of 2 on both sides, then divide by 2. Cosine theta must equal negative square root 2 over 2. Well, again, using the unit circle, cosine theta is equal to x. So now we'll look for an x coordinate of negative square root 2 over 2. And that's going to limit us to the second and third quadrant, since the x coordinate is going to be negative. So looking in the second quadrant, here's an x coordinate of negative square root 2 over 2. The angle is 135 degrees, or 3 pi over 4 radians. And in the third quadrant, here's the cosine value of negative square root 2 over 2, which is 5 pi over 4 radians. And again, to find all radian solutions, we'll just have to add multiples of 2 pi radians to both of these. So to solve these types of equations with sine and cosine, the unit circle comes in very handy. Let's take a look at this one graphically as well. Here's a graph of y equals cosine theta, and we have the graph of y equals negative square root 2 over 2. The solutions that we found on the interval from 0 to 2 pi were here and here, and these other solutions we see would be these values plus or minus multiples of 2 pi. Okay, let's take a look at an equation now that involves tangent theta. Again, we'll first solve this for tan theta by adding 1 to both sides, dividing by square root 3. So we have tan theta equals 1 over square root 3. Now this ratio should remind you of a 30, 60, 90 right triangle. If you take a look at a 30-degree angle, the tangent ratio, or the opposite side over the adjacent side, is 1 over square root 3. So that gives us our first measure for angle theta as 30 degrees, or pi over 6 radians. Let's also sketch this on the coordinate plane. Now remember that tangent theta is also positive in the third quadrant, where both the x and the y coordinates are negative. So if we sketch a 30-degree reference angle in the third quadrant, this angle would also have a tangent function value of 1 over square root 3. And this angle would be 180 plus 30, or 210 degrees, which is equal to 7 pi over 6 radians. Now for all radian solutions, remember the period for tangent theta is pi radians, or 180 degrees. So for this problem, we're only going to have one equation for theta. Theta will equal, we can use either of these angles, but let's use pi over 6 plus any multiple of pi radians. So we'll get this second angle and any other coterminal angle by adding multiples of pi to pi over 6 radians. So we don't need a second equation here for all radian measure, due to the period being pi instead of 2 pi. Let's look at it graphically. Here are the two solutions we listed from 0 to 2 pi, but you can see all our solutions will be multiples of pi from either of these. We chose pi over 6 for our equation. Let's take a look at another equation. 4 cosine theta minus 6 equals cosine theta. Well, in order to solve this for cosine theta, we must get cosine theta on the same side. So we'll subtract cosine theta, add 6 to both sides, then divide by 3. Cosine theta equals 2. Remember, the range for cosine theta is actually the closed interval from -1 to +1. So cosine theta will never equal 2. Therefore, for this equation, we have no solution. Let's go ahead and take a look at this one graphically as well. Here we have the graph of y equals 2, and there's y equals cosine theta. Since they don't intersect, this verifies our answer of no solution. Okay, I hope you found this video helpful. Thank you for watching, and remember, this is just the first of several videos on solving trig equations.